Hi everyone, welcome. In the era of precision agriculture, real-time data is critical for crop sustainability. However, monitoring plant health often remains a manual and reactive process. Today, I'm presenting the Smart Plant Guardian, an integrated system designed to automate plant diagnostic to HAI and Internet of Things technology. So this is a tomato plant. This can scream when there's thirsty. So I create this capacitive soil moisture sensor in the dirt since the pipe can read analog signal. Directly, I use the module called ADS1115 ADC to translate the plant's thirst into the data that I can understand. Okay, now this is the demo for this project. And yep, I run it for this project. And then you can see a bit lagging, but it's okay. So I make it in Indonesia, like a 10-second preview. And you can see this will capture. I think I have to adjust camera first. The system architecture is built on multimodal sensing framework. We utilize a Raspberry Pi 02W as our central processing unit. The perception layer consists of two primary inputs. First, a high-definition visual feed for leaf analysis. Second, a capacitive soil moisture sensor interface via an ADS1115 16-bit IDC to monitor the rhizosphere's physical condition through the I2C protocols. At the heart of this project is a convolutional neural network deployed via TensorFlow Lite. By utilizing the PlantVillage dataset, the model is capable of classifying 39 different plant conditions across multiple species. To optimize performance for the Pi0's ARM architecture, we implement a 10-second polling cycle, ensuring accurate inference without overloading the system's 512 megabytes of RAM. Developing for each device presents unique software challenges. During the integrations, we address significant library dependence conflict, specifically ensuring compatibility between the NumPy and the TFLite runtime API. Additionally, the OpenCV environment was configured to support real-time previews, allowing for precise camera alignment before data is synchronized to the cloud. All diagnostic results, including disease level, confidence score, and moisture percentage, the Smart Plant Guardians demonstrated that low-cost devices can effectively bridge the gap between traditional farming and automated agricultural intelligence. Don't forget to like and subscribe for more over-engineered solutions for simple problems. Peace.